Cool. Awesome. Thanks, Emery. Okay. So Sarah, yeah, you're kind of correct with what was being said. So if we go through the first two examples, modulus of 7, modulus of -3, could I have two people just shout out what those will be?
Seven and 3.
Any takers? Modulus of 7, modulus of -3?
Sarah said 7 and 3. Can you hear us, sir?
Can't hear us. Tell him to leave and join back.
Oh, you can't. Oh, right. Okay.
Hello? You're muted.
Now I can hear you guys. So, modulus of 7, modulus of -3.
I said 7 and 3.
Oh, yes. 7 and 3. Absolutely. 7 and 3. And so if I give everybody a minute, not even a minute, 30 seconds even, to do number 1 and 2, and we'll see what people get.
Wait, sir.
Yeah.
This might be a stupid question, but with modulus functions, does it go under like second A level pure?
Does it go under what, sorry?
Does it go under pure? Is it
Yeah.
pure? Okay.
To be honest, I feel like this is better suited on a Jamboard. Hello.
Could you do with anything like
Cool. So what have people got for I know that was like a lot more than 30 seconds, but it's okay. What have people got for number 1 and number 2? Any takers?
For number 1, I got 12 because
Mhm.
it's 2 plus 3 plus 7.
Mhm.
And then for number 2, I got 21 minus 2 plus 20, which
Mhm.
is 39.
Yeah. Perfect. So 12 and 39. Are there any questions about that? That's just to get a feel for the function, what it does. And notice how when I was writing this, I made the lines really dark just to make it clear that it's not a 1, it's not any other little symbol, it's the modulus function. Cool, okay, moving on. Just to see that you really understand this, I want to see what kind of answers people get for these inequalities. This is going to make people think a lot more, but that's good. In fact, just to help people out as well, on slide 2 of the Jamboard, could people come up with some suggestions, some values that X could be? So maybe you want to write some numbers down and then we can discuss those before getting you to think about answers for this. So slide 2 of the Jamboard. Yep. Someone's writing X equals. Okay, right. Someone's telling me what X is not equal to. Yep. Yep, X can't equal 5. X can't equal minus 5. So can anyone give suggestions as to what X can be then?
Could you say that X is equal to minus 4?
X could equal minus 4. Yep,
That's
indeed.
yeah.
X could equal minus 4. But it sounds like you're going to say something else quite interesting. What were you going to say, Jackson?
Well, I was just going to say that's the highest integer that it can equal, because otherwise you're going into
Okay.
betas.
Sure, the highest integer it could be. Oh, okay. Someone's really gone off of what. In fact, they just had the same writing. Someone's gone off of what the person who said X is not equal to 5 and X equals not equal to minus 5 has written. Someone's put X is in between minus 5 and 5. Indeed, but X doesn't have to be an integer per se. In fact, what have I written in the box in the question? What have I said X can be? Yeah, X is a real number. So we've actually got an answer there for that first one. So an equivalent statement with modulus is the modulus of X is less than 5 is equivalent to, it's actually identical to minus 5 is less than X, which is less than 5. An equivalent statement.
Okay, so why can't X equal minus 5?
Because what is the modulus of minus 5?
Oh, right, okay.
Mm.
Right.
So as we're doing that second one, modulus of 2x minus 7, I'm writing it on the third slide, but so if people want to answer it on the Jamboard, you can. But the modulus of 2x minus 7 is less than 5. Well, now we can kind of think about how can we maybe use what we had beforehand to help us answer this. Felix, the Jamboard link for you is there. But we're just going through this thing called the modulus function. So let me copy this onto
Could I try to do the second one?
Could you try and do the second one?
Yeah.
Yeah, absolutely.
I don't know if I'm right, but basically what I did was, instead of trying to figure out every single one, I just did which ones I couldn't do and then found the range. So I put 2x minus 7 equal to 5. So then 2x equals 12 and x is equal to 6. Therefore, x can't be equal to 6. And then if you do that for minus 5, you get minus 6. So then the range would be minus 6. So x is greater than minus 6 and less than 6.
X is greater than minus 6 and less than 6, did you say?
Yeah.
Wait, so I got that you put it equal to 5. When you put it equal to minus 5, what did you do?
The same thing. I just basically rearranged it to find out what I couldn't get.
And tell me your steps for that.
2x minus 7 equals... oh, wait, give me a second. Okay, so it would be, the range would be x is greater than 1 and less than 6.
That sounds about right. It sounds like some students are agreeing with you on slide 3 of the Jamboard. So slide 3 of the Jamboard.
Sorry, I was doing it on another app.
No, that's okay. But yeah, good stuff. So do people have questions about this one? Yep.
Do you mind explaining number 2 again? Sorry, I kind of don't get it.
Number 2? Okay, so let's go. Let me make sure that I've got this bit recorded actually, because that's kind of important. Oh, 1 second. Felix, if you try the link again, it should work. That's all right. Okay, so I'm going to go on the fourth slide to re-explain the number 2 question. What was the number 2 question? 2x minus 7 is less than 5. The modulus of 2x minus 7 is less than 5. Okay, so did you get the first one, Nadia, the one with this one?
Yeah.
So this one meant modulus of x less than 5 means that x is essentially between 5 and minus 5. So the logic can also be extended to this, where we say that minus 5 is less than 2x minus 7, which is less than 5. So the thing inside the modulus has to be between minus 5 and 5. Does that step there make sense?
Yeah.
And then, if we add 7, on this side, if we add 7, we end up with 2. And here we're left with 2x.
Oh, I see. Because I just forgot to solve it because that was such a dumb. Okay, I just forgot to solve it.
Oh, that's all good. Usually it's the first step that's the hardest part. So if you've got that part, then the rest of it is okay. And then dividing by 2. And that's it.
Thank you.
You're welcome. Okay, so that third one, I thought the third one would cause some issues. So what is the third one? Is it 4x plus 1? Is that what it is? Yeah, 4x plus 1 is greater than 81. Has anyone else got any other suggestions before I say anything?
I got minus 20.5.
Minus 20.5, okay. Wait, when you say minus 20.5, what was your final answer?
Oh, sorry. It was x is greater than minus 20.5 and less than 20.
Let's try this. Let us pick a number that's in your range. So can we select a value for x that's in your range?
Sure.
So,
18.
okay. And let's put it back in the original question and let's see if it works.
It works.
Does it?
Yeah, 73.
Is 73 greater than 81?
Oh, this is greater than. Sorry, I read it wrong.
So well, yeah, that's the other thing as well. Is minus 20.5 greater than 20? So this is where it's a bit interesting. Yeah. Question is, why is it that way around? Can someone explain from the beginning what's going on? Any takers? Any explanations for why it's that?
Is it sort of to do with how when you have a quadratic and it's greater than, it sort of goes off in the two tails to infinity rather than in an enclosed section in the middle?
Indeed. Yeah. And in actual fact, we'll learn a bit later that a modulus function can actually be, modulus equations can actually be solved by squaring the quantities. And it becomes like a quadratic. Because when you square a quantity, that also removes any negativity and leaves
Okay.
negative values. So there's a very big relationship there. Let's start from the beginning then. So I'm going to write in red on slide 5. If 4x plus 1 is greater than 81, that means that the entity inside the modulus function, 4x plus 1, it's got to be greater than 81, or 4x plus 1 must be less than minus 81. Because remember, if the thing inside the modulus gets more and more and more negative, the output would just be more and more positive. So if the thing inside the modulus was minus 100, the modulus function will output 100. If the thing inside the function was minus 200, the modulus function would output 200, and so on. So as you get more negative, the inequality continues to reign true.
I can't really see how that works for me.
So imagine this. What's this going to be?
Positive 100.
Right, that gives you 100. Does that satisfy the inequality?
Yes.
Yeah. What about this?
Yeah.
Okay, what about this?
No.
No. So at what stage does it work?
Will surely be anything from like what's it from minus 20.5? That's where it works from.
Okay, you're kind of solving it, but yeah.
Yeah.
Essentially.
But why? So what? So that's not. I'm confused. What? We wouldn't put minus 70 in working, surely.
Sorry?
What? Like, what part is the answer? The minus 20.5.
So, okay, right. This is me replacing the whole of 4x plus 1 as 100 as minus 100.
Okay. Yeah.
So we know that minus 70 doesn't work. We know that minus 81
Doesn't work.
that's equal to 81, right? But that's like the boundary of where it works. Like
Yeah.
at that point, that's like the tipping point when it goes from it works to it doesn't work.
Yeah, anything above that. Yeah.
So here, well, when we say anything above that, really we mean
Or anything less than that.
exactly. So that's why I've got in this bracket 4x plus 1 is less than minus 81. Because if I can solve that inequality, then I've got all my values below minus 81 that work.
Why could we switch it around?
What do you mean?
Like why can we change what's greater and what's less than?
Well, so if you think about just numbers in general,
Yeah.
which modulus numbers are going to give you something greater than 81?
Yeah.
So which
Yeah.
numbers?
Yeah. So I don't know, minus 82. Minus 82 gives you
Right, which is less than minus 81. So we've put this quantity less than minus 81.
yeah. Oh.
And now if
Okay.
we solve that inequality, 4x is less than minus 82, x is less than minus 20.5. That's part of the inequality, but there's also the other part where 4x plus 1 is greater than 81. So therefore, 4x is greater than 80. Therefore, x is greater than 20. So we end up with this kind of inequality. X is less than minus 20.5. Union, x is greater than 20.
Oh. So that's for all. What's it? It's basically saying for all of the possible values of x.
That's it. Because when you solve
Okay.
inequality, we
That
solve
makes
it in
sense.
such a way that we work out all the possible
And
values.
because minus 81 goes down rather than up if you're adding or if you're subtracting. I don't know. I know. I get it. I get it. Yeah.
If you go, like the way to get, as you get more negative, the number itself is getting bigger, but the negative
It's
means
getting lesser. It's yeah. I see.
it's always a very weird concept. Mhm.
Yeah. No, I get it.
That's it. So, are there any questions from people about that? Okay, if no questions, I'm on slide 6. Mina, can you come up with a question that we're all going to try and solve of some kind, an inequality with a modulus? It can be anything you like. And then I'll give everybody a few minutes to try and solve it.
Okay, I can try. I just need to. Okay.
So on slide 6, we are looking at the question that Mina's going to provide for us.
Sir, is Sir there?
Yeah.
Hi. Sorry, I had to go to the toilet. Do you mind just explaining the union part?
So basically just means or. So x is less than minus 25. X is less than minus 20.5 or x is greater than 20.
Okay, I see. Thank you.
That's all right. Okay, so 8x minus 3. Does that say the modulus of 8x minus 3?
Yes.
Cool. Thank you for that question, Mina. So the modulus of 8x minus 3 is less than 37. Okay, guys, let's do it. And anyone else who's feeling adventurous, I invite you to create a question for us on number 7. And if that's okay with you, I've created a question on slide number 9, which is a bit more challenging. Cool. Okay, so I've put a more challenging question on slide number 9. For slide number 6, any takers? Someone who hasn't spoken yet. I just saw Lucy's message. That's him looking at the call. Emery, since you share Mina's birthday, any takers? Any ideas? Sorry.
Can you give me a second? I'm working on it. I just,
Mhm.
yeah, I think I've nearly got it. Just give me a second, please. Thanks.
Okay. No problem. And if anyone's looking at the one on slide number 9, it might be worth using the actual the formal definition, maybe, unless you've got other ways of doing it. But it might be worth using the formal definition given on the first slide to help you out.
I've written my answer down. Don't know if it's right, but yeah, give it a go.
Okay. How did you go about doing it? I want to know about the process.
Okay, I kind of just I know like on the other slides we like took it apart, but I just kind of went through what can you times by a, and yeah, I didn't do it a very clever way. I just went what can you times by a and minus like 3, and then I realize is 8 times 5 is 40, minus 3 is 37, so it can't be anything above that. So it's obviously gonna, and you can obviously use minus 5 as well, because that's gonna turn it into turn it into a positive. So I think it's from -5 to 5.
Yeah, that works.
Okay.
Oh, actually, wait.
So I got something different.
Is that true? The 5 bit is correct.
Mm-hmm.
The 5 bit is correct. I spoke a bit too soon. The -5 bit, though. How did you get the -5 bit? What was your thinking for the -5? Tell me that last bit one more time.
Wouldn't that do minus? Wait, I don't think that works. No, because if you use -5, that makes it. Yeah, I don't think that works because that makes it -40, and then -40 minus 3 is -43. Yeah, that doesn't work. Okay, yeah, it has to be something else because it makes -43, and that turns into 40. Yeah, that won't work.
Can I suggest?
Go for it.
Yeah.
So I got -4.25.
How?
I'm hoping that's not I'm wrong how, but I did 8x minus 3 equals -37, which got me 8x equals -34. Then I did -34 divided by 8, and I got -4.25.
That sounds good.
Oh, okay. You scared me.
Why?
Because you were like, how? Like you
I
were
asked how.
saying as if I got it wrong.
No, I asked how. That works. Yeah. So, well, actually, we should be asking Mina because it was Mina's question. Mina, was that the answer that you were intending for everyone to get?
I don't know. I made the numbers up as I went, and I got the same answer, so I guess it's correct.
There we go. Mina spoke. It's correct.
Sir, should it be written as universal or not?
When you say universal, do you mean?
Well, because you said it's for all values of x before, right? So I don't. If you get for -4.5, 4.25 is less than x, and 5 is greater than x. Do you write that as universal or not? Like, because what you did on the last one, you put universal. So.
When you say universal, are you talking about that U thing?
Yeah.
That means union. So that was a situation where we had two disjoint sets. And that was because it was a greater than situation.
So is it not the same thing on the next slide?
No, because this one, you can actually have it all in one continuous set. So we just have the one inequality. Where it's not possible to have it on one continuous set, we have to have the two separate inequalities, but this one is fine.
Okay.
It goes back to solving inequalities when we did it in first year. Some inequalities will have one set, and then others will have two sets.
Yeah. Okay. I think I get it.
Cool. Okay. Any takers? Someone who hasn't yet spoken for slide number 7. Participation is what's going to get you the most out of it. Just saying.
So I don't mind doing it, but I feel like I've already talked.
No, I know. I want to try and get people who haven't yet said anything to, because I want to check that everyone understands. So I know, Sarah, you've got an understanding of this. Emre, I know you've got an understanding of this. Jackson, you've been asking questions, so again, I know you've got understanding of this. Annika.
Okay, you might not be able to hear because I'm in a kind of noisy room.
That's okay.
But I'm not sure about this one because, well, I tried it, but obviously there's not really the difference, like negative 0, negative 0, positive 0. So I thought it was just one inequality.
Say that again, sorry.
Is it just one inequality?
Well, let's see.
Sorry.
So that's not telling me what you.
Whoever created this, wow.
Yeah, I don't know quite what I created.
I thought you knew what you were doing, so I was going to say that is like conniving, which is like really good.
I just thought it would be interesting to see with 0 because that doesn't have like a negative. Yeah.
Yeah, I was able to do the other ones, but I just don't know if I can do this one.
Say that again, sorry.
I was able to do the other ones, but I don't know if I can do this one.
This one actually doesn't have a solution.
Oh.
Yeah, this one was evil. Like that, whoever created that, my God.
Oh, I'm sorry.
Yeah. This one doesn't actually have any solutions if we're talking about real numbers. And I thought you knew what you were doing when you did that. That's why I was like, wow.
Oh, I see why now. Because everything on the left side will be positive, which can't be less than 0.
So.
Okay.
Yeah.
What if we put it greater than 0?
Greater than 0, then it will function just like just normal 7x plus 5 is greater.
Oh, yeah.
Because
Okay.
we know that the modulus function is always greater than or is always greater than or equal to 0.
Mm-hmm.
So yeah, this one was the, I don't know, yeah, the terror question. Let's just call that. But yes. And a half x plus 6 is greater than 50. The modulus of a half x plus 6 is greater than 50.
I don't mind doing this question.
Yeah, okay.
So first of all, I split it into the 2 different inequalities like we did with the other one.
Mm-hmm.
So I said a half x plus 6 is greater than 50, and then a half x plus 6 is less than minus 50.
Nice.
And then I worked out the left side, so it was 1/2 x is greater than 44, and then x is greater than 88.
So a half x plus 6 is greater than 50.
Yeah, and then 1/2 x plus 6 is less than minus 50.
Mm-hmm.
And then on the left inequality, 1/2 x is greater than 44,
Mm-hmm.
and then x is greater than 88.
Mm-hmm.
And then on the right inequality, a half x is less than minus 56,
Mm-hmm.
and then x is less than minus 112.
Yeah.
And then you just do the union, so x is greater than 88 union x is less than minus 112.
That's it. That's the one. Thank you, thank you, thank you. That works. Any questions about that? Okay. This last one was an interesting one. So I mentioned using the definition as a way to start, maybe, but let's just suppose even that was a bit difficult. Did did anyone maybe try some different values of x that could work?
This might not. I haven't actually started doing the question yet.
Okay,
but,
no problem.
And I don't know if this will work, but could you not like what's it called? Could you not do like 2x plus 7 plus x minus 7 and then like, if that makes sense?
Okay, so then what would you do?
So like 3x. So 2x is plus 1, x is 3x, 7 minus 7, 0. So 3x is greater than 3x is less than 10. I don't know if that would work though.
And then, so I mean, again, the only way you'll know is if you try it, right? If you try it and you get an answer, then try and substitute some answers in and see if it works.
Okay.
Mm-hmm. So someone's put if x equals 2, 2 times 2 plus 7 plus 2 minus 7 equals 6. How did you get that? So sub in 2. So 2 times 2 is, and then plus the 7. And 2 minus 7 is, and then the modulus of that is, So this number 9 was actually quite a tough one.
So I put what I got on the top right.
For that number 9 question.
Yeah.
So we established that if x equals 2, that doesn't work. So maybe there might be some values that work. But we definitely know that not all of them will work because we know that 2 doesn't work, for example.
Using a calculator, I've tried a bunch of integer values,
Mm-hmm.
and the lowest I could get it to was 11 when you sub in -3.
Mm.
So I don't know if it's possible for that to be less than 10.
Mm. So, what do other people think? Here's a question. What is so the lowest thing that you could get it to be was 11. So I guess one question we can ask ourselves is, what is the smallest thing that these modulus functions could be? How do we get those values of x? But we can also just use the definition. It's a bit of a hard one. Okay. We can work up to this. Let me make this a bit easier. On the next slide, on slide 10, sorry, on slide 10, let me write let's write an easier version of the question. Well, not even an easier version, just an easier question, but still quite a tough one. So this one has a few more values that we can try at least. Okay, so I see 0. Yeah, x equals 0 works. Someone's put x equals 15 is the highest value. Okay, they've changed it to integer.
So is there an easier way of doing these questions?
Is there an easier way of doing these questions? Maybe, possibly.
Right.
So let's use the definition. What does the definition say? The definition says that the function remains the same when it's greater than 0. So modulus of x plus 5 is equal to x plus 5 when, of course, x plus 5 is greater than 0, or when x is greater than minus 5. And the function also says it's the negative version when it's less than 0. So in this case, it's equal to minus x minus 5 when x is greater than or equal to, and when it's less than minus 5. That's for the x plus 5 function. For the x minus 6 function, the modulus of x minus 6 is equal to x minus 6 when x is greater than or equal to 6, and it's equal to minus x plus 6, because that's the negative version of that, when x is less than 6. So someone's worked out that the lowest integer is going to be minus 14. Okay. Happy days. But it's good that, I mean, yeah, x is a real number, sure. But it's good that people have come up with, with some boundaries. And this is a good way to work towards solving problems. You've got part of the solution, and now we just need to work out, okay, how can we make some more progress? And this is kind of why I didn't want to just say this is the way to do it, because I don't want to program robots to just come out with answers. It's kind of nice to be to have a chance to think about the problem and think about what's going on. You probably wouldn't be asked anything like this in your A-level exam, but one thing that we can definitely guarantee is you've now all got a very good feel for what the modulus function does. Can we say that's a fair judgment, at least, that you know what the modulus function does?
Mm-hmm.
Yeah.
Yes, sir.
Nice. So yeah, that was the whole point of these kinds of problems. So if you were able to try stuff, even get at least one value for this kind of question, then that's cool. I will show you though what needs to be learned in the syllabus, of course, so that you know what to focus on. But I think it is good to have these it is good to have these kinds of problems where you're able to just play around and explore, because I think that part is important. The creativity aspect is really important, as I'm hoping you guys appreciate being the people that you are.
So
yeah.